All right. So, hello everyone. I'm Daniel. So right now I am currently a data engineer / research associate at my lab, which is the Social and Decision Analytics Lab at Virginia Tech. It's part of the Biocomplexity Institute. I am also currently a PhD student, so I'm trying to juggle working and fulfilling a PhD, and I totally understand why some people will end up taking almost forever trying to finish their PhD now. And I guess, and my mom's there, so like I'm really like not making this easy for myself. So I guess my research question is really leveraging government, administrative, and open data sets for use for public health, mainly because I have a master's in public health and epidemiology from Columbia University. Yeah. One of my former professors is also out here too, Dr. Melanie Walt, so she's out there. And I do work for Jared Lander, and a lot of the, I guess, experience from standing up here and talking to people comes from the carpentries, which is software and data carpentry. And I also have one data cam class that's out, and I'm recording one on Sunday, so there's that. And so the first thing I want to say is thanks. So this isn't the end of the talk, thanks. This is a so this is a thanks to the community, to all you guys. I'm saying y'all because I'm currently at school in the South. And so, so first of all, to RStats NYC, it's pretty much how I got my beginnings of how to learn everything, presenting, and just constantly learning. When I moved down to DC, there was the Data Community DC thing, which was essentially, when I went down, was how do I find what I had in New York down in the DC / Virginia area. And then there's everyone else that I've met along the way. The Pi data community, SciPy has been really awesome. They have their conference every year in Austin, Texas. And then last but not least, there's the carpentries, which, those of you who don't know me, I do a lot of teaching, and this is actually where all of my teaching experience, well, most of them, come from. And so yes, this book, this thing happened. As you can see, there was like a tweet from 2016, so it was like a many-year endeavor. This is a picture that my sister drew, and I'm posting a tweet mainly because like she doesn't own that picture anymore, so I didn't know how to post the rights of that picture, but so there we go. So this talk, it's called Doing Data Science, and this isn't our conference, and I wrote a Python book, and I'm talking to you guys, but it really comes down to, like, it's really not R versus Python, just like Hadley Wickham said a few days ago. It's really R and Python. Like, the two communities can totally live together. You don't have to pick one or the other, but if you are learning, pick one that you're learning, that your friends are learning so you can work together, because over time, you will end up learning the other language just by meeting everyone and being in the community. And if you didn't know, I mean, at the end of the day, we're also all friends, right? And so if you didn't hear this news that was posted yesterday, if Wes McKinney and Hadley Wickham can work together and start a project together, then we can all definitely be friends, right? And like, even more, like, if I had to say anything, it's more like the R community itself. Like, if you've ever seen like the old Stack Overflow comments and tirades or snark between Dirk and Hadley, it's more like what's wrong with R within itself than like this R Python thing going on, right? So what is data science? So this is a slide I sort of stole from the Anaconda folks from the Python side. And it's a pretty good graphic on like, there's so many buzzwords, like what is it, right? And so one of the ways you can break this down is like, you can break down tasks by what are the actual tools you're using. So data science, data engineer, I kind of play both. And like these days, more or less, I'm working with data sets and databases and getting everyone in my lab the data set that they need. And then they start the process of analyzing it. And so, there's a bunch of overlap. We all do similar tasks. So, this all ends up being like almost a continuum than like individual roles. And so last year, if you weren't here, I essentially took all my experience from running 2-day workshops and compressing it into a 20-minute talk. And one of the things that I did or talked about last year was about this paper about structuring your projects. And this is a paper by William Noble. And in this paper, he has this figure, which is how to structure your R projects, right? It's very easy when you just start off that all of your files and scripts and output all end up in one folder, and then you end up with this problem where you have 100 files and you can't find anything, right? And so he's saying that, hey, here's an academic paper, so maybe people will start doing it in academia, how to structure your projects. And once you have a folder structure, you can start scripting it. So there's this reproducible science curriculum that has a script. I wrote a script. And it's really like a bash script that creates some files and dumps a README or a git keep file so you can check it into version control systems. And if you remember either Jared's talk last year or the year before, you can also just write all of this in R, right? You don't even have to leave RStudio to make this happen. And then so Greg Wilson, which is one of the co-founders from Software Carpentry, him and a whole bunch of the Software Carpentry team, they all wrote a paper in 2014 about best practices for scientific computing. And then they tried to update it in 2017 for what's good enough. But what ended up happening, they really just talked about hey, write functions, write loops. If you're copy and pasting something 50 times to run something 50 times, you're probably doing it wrong. Plan for mistakes, start checking other people's code if possible, version control, collaborate. And the good enough paper really just sort of shows you a little bit more about how. And I'm talking to you about this mainly because my lab, we run a summer program called Data Science for the Public Good. And essentially what happens every summer is there's around 15 undergraduate students who don't know anything about R. A lot of them have never seen this before. And then 5 grad students to help lead various projects, right? And so there's this whole influx of people that I'm mainly tasked to teach. And so they stress test every part of what's easy to learn, what's easy to do, especially if someone writes really bad R code, you don't crash the server for everyone. And then I get phone calls in the middle of the night, and then that's what I have to deal with. So how do I make my life and their life easier is really what I'm trying to talk about. And so the first thing that we've gone over in my lab is we just moved everything to Docker. And I sort of wrote this process. So this was about a 3-year process where we moved from VirtualBox to LXC containers, and now we're working with Docker. And that's just really great because when someone does mess something up, and actually more often than not, it's really me messing things up, you can take off the Docker container, spin it back up, and you're exactly back to where you started, right? You don't have to be worried about well, what was that command that I ran? And if you actually want that to be permanent, you put it into the Docker file script, and then that will be persisted, and you've fully recorded all your steps for that particular snapshot. And so this is essentially what our lab's infrastructure looks like. Each one of these boxes is roughly a Docker container. And so we use, for the most part, Microsoft R Open. But we also have a parallel one that's running just R. And the main reason for that is Microsoft R Open comes with the Intel math kernel libraries pre-installed, so you don't have to recompile R by yourself. So that's the main reason why we're doing it. And then on top of that, we have our RStudio server and our Shiny server. And I have a special container just for installing R packages that I'll talk to you about. But just like that Noble paper, you can structure your project templates to exactly how you need, right? That was just a paper to just make you think about it. And so I've adapted that to make it something much simpler, where you have a data folder, you have a source folder, you have an output folder, and a README, and then everything's in our project because we're in our lab. And so within data source, this is really a symlink to somewhere else on the drive because you don't want to be checking data sets into version control. And so that's the part that's highlighted in orange. And I've essentially told my lab, we just, in here, create 3 folders. Original, working, final, where original, that's where you got the thing from. You make those things read-only. You never touch that ever again. Working are the things that, this computation took about 3 hours. I don't ever want to run this again, so I'll save it somewhere. And then final is, this is a data set that I fully cleaned, and I can fit my model right away, or I can fit a plot right away. You don't have to, redo an analysis script or a cleaning script. You can just base it off of that one plot. So that's sort of what we've moved to in my lab. And so how do we install R packages? So we have this separate Docker container for R packages. And so what this lets me do is I can install an R package for everyone, because if you're on a Linux system, every single R package is essentially compiled from source. And if you're doing install.package as tidyverse, that's going to take forever, especially like the first day when 20 people just got their new system and you're just sitting there waiting, and hopefully like our servers don't crash. And then here, so the thing, if you want something installed for everyone, or we're trying to install all of these packages into one folder called R packages. We want that to be loaded into the order that R looks for when you try to load a library. So it's like a path. And if you want to do it for everyone, you look for a file called rprofile.site. So everyone has a .rprofile in their home directory, but the rprofile site does it for everyone. And so in here, we pretty much say, hey, we're changing the lib path, we're prepending, so it's right there. R packages in front of everything else, so that gets loaded first. And then what we do if we're trying to install a package in the R packages container, I say install packages. And then this allows me to say, like, if I do need a system library, for example, like SVG or JPEG or something, I can test everything out in there and then slowly build up the whole R stack from Microsoft R Open to RStudio to Shiny. And when that's done, we say Docker push, everything goes to Docker Hub. And then on our production server, we say Docker pull, we get all the brand new images down. And then we turn on and off containers as needed and load them back up, right? So there's this no recreate flag that I learned the hard way that exists. And if an existing container is already running, it won't turn it off and turn it back on. Because I've definitely ran this command without it, and I've like stopped someone's like compute that was like 3 hours in, and I was like, sorry. And then, so everything is running on RStudio in our lab. And the open source edition is great for individual use. But I'm slowly starting to realize we're like trying to build the R Pro stack that everyone at RStudio's been working so hard, because now I'm like down this rabbit hole of like, all right, there's Nginx. And like, I have a master's in public health. Why am I looking at Nginx? Which is like a web server that helps do things. So we're in the process of exploring RStudio Pro, which should probably just solve many of those problems. But at least for us, because we're trying to avoid paying for RStudio Pro, everyone has their own RStudio container, right? So if you tank a container, you can just restart it, and I don't have to worry about it. And that helps really well with like if you're working with like groups to manage permissions and stuff. And then for authorship in our lab, we have Overleaf. And so one, it's really nice that everything is Overleaf and ShareLaTeX both have real-time editing and rendering. And you can, if you look under the hood a little bit or click around, everything is a Git repository. So you could also work with it offline. So we use Overleaf. Our university provides us with a pro account, but I think that just limits like how many figures you can actually upload or something. But because we're also using Docker, you can just run ShareLaTeX on your own machine, and they have a compose file that'll set up ShareLaTeX, MongoDB, and Redis, and you can actually just log in on your own laptop or on your own machine, play around with it, and then slowly figure out how to like implement it in your own system. And then we have this thing where a lot of our coding, so back in undergrad, I did neuroscience, and I was a bench lab researcher, and I've gotten carpal tunnel in my thumb. And so we always had a lab notebook, but now all of our stuff is electronic, so we need to start documenting like processes, like especially when we have external clients. We want to be able to show them like stuff. And so right now, our whole system is built on Drupal, because I don't know why we picked Drupal over WordPress, but we're sort of, we hired someone new to help along, and he knows Python, so we're now down this whole Python Django Wagtail stack, which is a content management system that we can like start automating the whole like, hey, when you click a new project, it does all of the back-end stuff already, because I really didn't want to learn PHP, because that's what Drupal is. So what are the skills that you need? Git is really hard, and the shell or bash is the glue that essentially will keep everything together. And so, Greg Wilson, he's currently the head trainer at DataCamp. DataCamp's been mentioned many, many times already, and they're essentially poaching the community. But he was the co-founder of Software Carpentry, and that's where I got my beginnings. And he wrote these 2 really amazing courses. Because Git and Bash are so essential, they're totally free on DataCamp for those, if you want to learn that on your own. And so at the same time, I teach for Software Carpentry, so they have all that free material out there as well. And so then how do you balance good practices with just straight up getting work done? So Titus Brown gave a talk at my university, and I had to go meet him. And essentially, he said, just write functions, right? You don't need all of this infrastructure to write a function. And you don't need, you'll read a lot about hey, everything should be a package. But you don't need to write a function and then convert it into a package, because then updating the package is kind of really annoying. So as long as you start writing functions and then you think about moving it into a package as you start using functions for your one project more and more, then you can start thinking about moving it into a package, right? You don't need to say oh, I'm writing this project, every function I need needs to go into a package. Don't do that, because a lot of those functions you probably won't use again, right? But at least it's a function, so you can reuse it internally if you need to. But really don't write this in your R code, right? Don't set a working directory, use R projects or something. There's even a function that you can make people copy and paste in RStudio, so they actually open an RStudio project. If they're not paying attention to where they are. There's 2 other really amazing packages. One is called here and R project root. And essentially, it will find things for you within a project hierarchy. So you really shouldn't have to find set working directory, right? So I have a folder called functions. It's in this Shiny folder. And I can just say, here, just go find me this. It's in there, Shiny, and there's a thing called functions. Just give me a path, and then I can source the whole thing for you. So you don't even need to write this if interactive thing, which is what I used to do all the time. And then here is just a higher level interface for our project root. And then saving things. You can always save things to CSV. I used to always say, hey, use the base save and load function. But I actually more recently found out that base also has these save RDS and read RDS functions, which is actually a lot better, because what happens when you save something, when you load it back up, those variables, whatever state they were in, come up into your environment. So if you had another data frame named df and you loaded something, you just overwrote something, and that's not good. So save and load, so read RDS actually lets you assign it back to a variable of your choice, so you're not just overwriting random things in your environment without knowing. And then secrets. So how do we deal with random passwords we especially don't want to put it into Git? So there's this get pass function that's pretty generic. It can call the RStudio API to ask you for a question if you're in RStudio. It'll prompt you in the command line if you're running scripts in the command line. And then there's the secrets library. So in here, there's the get pass from there. But in get secret, the secret library, it can use the SSH key to encrypt other things. So in my lab, we use this to encrypt our passwords, so you don't have to constantly put in username and password when you're getting data out of a database. And that's also really useful when you start knitting documents, because when you click knit, there's no actual way to put in user input, or you're hard coding your username and password. And there's no reason why students should have my password, because they will have sudo root access to everything. So packages, there is all that. So that is an example of something that we put into a package ourselves called SLR. I haven't moved it up to CRAN yet, but there's a great free book about packages that you can read as well. And then I gave a talk about testing. And in the end, I want to talk about cookbooks. So R Markdown is really, really powerful, and I've given 2 talks about them. And there is this free reference called the R Graphics Cookbook, and there's also a book accompanying with it. But from the Python world in 2015, they were having this problem of coming up with a better color map, right? And so there's this color map called Verdis that they made because MATLAB made a color map called Perula, and they didn't allow anyone to use it. So they were like, OK, let's create our own. And so Verdis, if you're from the Python world, it's named after a snake. If you don't like Python, it's a fish. If you're really attached to MATLAB, it's named after a bird. So Verdis, this is what Verdis looks like. And it's an actual R package that you can use for your color maps. And this is a really good color map because it can print in grayscale. It's colorblind friendly. And Noam Ross, who is one of our speakers, put this together for the R community. And one thing I want to talk about is hey, there's color maps Start thinking about specific color maps for yourself for specific variables. So when you're working as a group, you don't have to think too much about what you're looking at. And there was a great talk from the Python community as well about how an oceanographer has specific color maps that they put together. And if you really can't be bothered, there's the Colorbrewer, which I use to just help you pick really good color maps. So you can check off if it's colorblind safe or print friendly, and you can get a nice color map out of it for yourself as well. And then other things, make cookbooks as needed, make your own flight rules. There's a really good flight rule repository about how you can use Git without just starting over and recloning things. And then so why am I telling you all of this? Well, from Greg Wilson, our planet needs our help, and we need good science to fix it. So thanks, everyone, again. All right.
Thank you, Dan.